want to show you something called BlackTrax today. And I know you've all been sitting there, and I'll make this as short and as sweet as possible so you can get out of here soon. But we think we've come up with an answer to a live tracking system that works in our industry. And I've been chasing this one for many, many years now to try and come up with a solution. And we call it BlackTrax. And Joan, it's not changing.
Okay, that one.
That one, thank you. So for many years, people have been trying to track live people on stage real time, and it's been a problem. There's been some solutions before us that have tried to do this. I don't think that they've passed the test. What we've come up with is BlackTrax, which is the ability to track anybody on stage, and we can actually track up to 3,000 people with unique signatures. We've got a first phase going out soon that's going to be ready by around next April, and it's really just about targeting and tracking people. It's a vision-based system, and it's very easy to install, and it takes about 10 minutes to calibrate once it's put in. So when I say vision-based, I mean it's a camera system, and it's going to be backed up with an accelerometer system after the fact, phase 2. I'll just keep going through here very quickly. The idea is, and I'm an ex-lighting designer, we won't miss a cue anymore. People will be on target, things will follow them, audio will follow them, lighting will follow them, and everything will happen seamlessly. And then on the other side of the coin, spontaneity with Mick Jagger running across the stage and wanting to be in the light all the time will happen, and he won't ever get out of the light as long as this works properly. There's another slide in here which talks about interactive tracking in museums and things like that. This is where this is all leading to, so that people can be interactive with their environment, their audio, their media, and again, BlackTrax will solve that problem. Location, location, location. Really, this is just talking about all of the different venues that need tracking. Mary Poppins needs tracking, Tinkerbell needs tracking. A lot of the problems that we've seen that can't be solved today, we think we've got the solution again to. How does BlackTrax work? It is a camera-based system. It looks for an infrared LED on a pack. I won't get into it too technically, because again, you're all going to go, I've had enough. But it does have a backup system to it that will keep the tracking going if the LEDs get covered up. And we think we've got this all covered out. I should say we have got this all covered. Let me be confident about this for you all. And BlackTrax will work as a standalone product that can go in and work with anybody's systems. And it will also work with something else we've got, which is called BlackBox, a communication system. I'm afraid I'm not doing this much justice because I don't have the equipment here with me. And if you get a chance to come by and have a look at what we're doing, it might help. And I invite anybody to come and have a look at what we're doing. We're in booth G15. And there's the invite to the booth. And very quickly, that was the speech, and I hope it didn't take too long for you. Any questions?
How does it work?
How does it work? Do you want the technical, how does it work, or the...
Yeah, try the technical resume.
Well, it's a camera system, so it's vision-based. You put cameras and surround your subject. We can cover up to 45 feet of area, and the cameras look for an infrared LED, active LED beacon that we're building, and it locks onto it with a centimeter accuracy.
And the LED beacon is powered, or is it passive?
No, it's active, so it's powered. And it has to be that way because we want to distinguish between all the other reflective LEDs, infrared in the set.
Yeah.
So we've got an active system, and it is powered, and it does have a unique signature so it can be identified. So once you're wearing one of these tags, and it literally looks like the diamond in a ring that you can wear on a costume, you can sew it into your costume. To you, it would look like a wireless microphone pack. You wear it on your belt, and in phase 2, it will also be able to give instructions back to your lighting systems to give controls and cues.
But if it's just picking up a single spot of positioning, should the system, how does the system know that they're going to turn left? I mean, in the old days, as we were discussing earlier, radio follow spot systems that were being used in America,
well, the tracking,
the tracking would follow the person, and then the person would suddenly turn right, but the follow spot couldn't compensate for that. It was always behind the move.
Well, that is a problem, but we think we've solved that problem. The tracking system is fast enough itself that it responds. Okay. And so, how fast? 240 frames per second at a centimeter accuracy. So it is fast. Our problem actually is not the tracking system, it's the hardware connected to it to respond in time for us.
Yeah.
Historically, having used these kind of systems in the past, I've abandoned them because they're a very blunt instrument. So you attach a sensor to somebody, you tell a light to follow the sensor, and it's never as good as a follow spot operator because it can't do a head to toe shot, for example. It will center the beam on a particular, wherever the sensor is, and it then can't compensate for the positional difference between the light and the sensor, so it will always be in the middle of, dropping from everywhere here. The sensor relative to the light might always appear to be in the right place, but the effect you're getting might be cutting the guy off at his head, depending on the throw of the light at that particular point. So how do you compensate for the fact that if a performer's getting very close to the light, the beam's going to be smaller, so actually you don't necessarily want the sensor to be at the centre of the beam because that might represent chest to knee rather than waist up.
I have to apologise. I haven't told you one part of the system that you need to know. We do all of this through the virtual world. We use our WYSIWYG 3D setup to make it all work.
Right.
We build and calibrate the system within WYSIWYG. We understand the coverage.
Right.
It all talks to WYSIWYG, and WYSIWYG will actually be bundled out with this.
Right.
And we can automate zoom and iris and everything from the same system. In the virtual world, we know all the distances between all the objects. So when somebody walks towards the camera or towards you or towards the follow spot, we can automatically iris open to cover them.
Okay. Cool.
So that's why we think we've got a better solution than what's been happening in the past.
Yeah. All I found in the past was it would follow people to the toilet, and when you wanted them lit, it would light their bum usually.
We can do other things. Good. We've got the ability to put what we call no-go areas in, so that when somebody leaves the stage, the lights will douse out. There's all sorts of things we can do with this system. That's what I'm saying. Unfortunately, standing up here and talking about it doesn't really do it justice. And even if you're not interested today, come by to the booth G15 and have a look just so that you can understand where we are going with this.
You have one LED on each person, or can you have multiple LEDs? So can you have one on the front and one on the back, so when they turn up stage,
actually what we're doing today is what we call a cluster of LEDs. We're actually running 3 infrared LEDs tightly close together on a person, and that's all we need to track them with.
Okay, and that's in 3 different planes, so...
No, that's in the same area, close together, and that's what we're tracking.
So if you've got 3 LEDs on your chest and you turn up stage, can it still see you?
What we're doing is circling the subject with cameras all the way around.
Okay.
And we've got it all worked out that on a 40-foot or 50-foot stage, we need 12 cameras, and all we need is 2 cameras to see those LEDs at any one time.
And if you need to take into account pieces of set flying in and out, can you have extra cameras?
Yes, you can. You can put cameras in any area that you need extra coverage. And obviously what you do is rehearse your show, see what happens, and then if there's an area that you don't get enough coverage in, you drop another camera in.
And what happens if for some reason they put on a piece of costume that covers the LEDs?
Well, they shouldn't. What we think is going to happen is they'll build the LEDs into their costume. When they change costumes, they'll literally unplug from the pack and plug the new one in, and all the smart's in the pack.
What does happen if in a show situation, for whatever reason, the LEDs become covered?
Okay, with the pack, in the pack is what we call a triple inertia system, and that gives you a direction and a movement, and it will take over and run it until the LED becomes visible again. So we've got 2 systems working together. You've got the LED system giving you X, Y, Z. That's picked up by the camera, and then what you'll have is an inertia system wirelessly reporting back through a wireless system again, secondary. And when one gets occluded, the second one takes over. And you can actually go quite a distance, and don't ask me how far yet because we haven't done the test, but you can go quite a distance before you'll lose it. And as soon as you see the LED, the system's back online to the LED.
So technology-wise, it's a combination of the new PlayStation 3 hardware and the older Nintendo Wii hardware.
Yes, and it's a whole bunch of different technologies plus our own technology in building it and software that we've written to make it work.
How many LEDs can you use at the same time? So how many people, how many tracks?
Actually, we can see up to 3,000 if we want.
Okay.
It's
And
way above anything we need.
the systems I know worked sometimes, and they had an accuracy of maybe half a meter or a meter. What's the accuracy of the system?
1 centimeter. That's what I mean. You need to come and see it because people just don't believe we can get that accuracy. We're doing it on a per pixel level because it's a vision-based system.
Mm-hmm.
I know. I've been into this tracking for many, many years looking for a solution. Our black box project needs a live tracking system to make it more viable. And we've answered all of the questions and concerns that we've had in this system already. But I know you're going to have more concerns.
Well, no, it was a simple question. That the stuff that you've cited, stuff like Mary Poppins, are installed theatre shows. By the sound of it, there's quite a lot of setup time required. No? So you could tour it or you couldn't? You can tour it if you want. We don't intend to tour it in the beginning, but the reality is once you've mounted the cameras and you would know exactly where you need to put them because you're using WYSIWYG, and WYSIWYG will show you all the angles of the cameras and it will allow you to change lenses on the cameras and decide where you can place them to get your coverage. You set it up as you do in WYSIWYG. The calibration once the cameras are set is about a 10-minute job. Right. So within the system, once you put the cameras in place, there's enough self-correction within the system that you're not spending hours and hours and hours setting your cameras. No. So it's how much time does it take to rig a camera? Yep. It's literally hanging the camera, turning them off, and off you go. Cool.
You're using, for example, 3 LEDs very close to each other. Yeah. Are you also tracking the rotation?
That's done in the inertia pack. Yeah. Okay. We don't have that here yet. That'll be phase 2 of this release. And the inertia pack is also the backup for the LEDs.
Okay.
And this is a product that's scheduled to go out by next April. Price point? If I want to cover a 45-foot stage with every eventuality I can think of with 12 cameras, and let's say we start off with 12 beacons, you're looking at around $50,000. Well, it's actually not just follow spots, it's spatial audio and a whole bunch of other things.
How are you interfacing to that? To spatial, how are you interfacing to other systems other than lighting systems?
We already have a developer program with WYSIWYG that talks to and connects over Ethernet to motion control, lighting control, media servers. And this is an extension to that protocol. And it's basically, it's UDP, TCP protocols.
And that, I mean, from an audio point of view, I noticed outboard electronics up there. That's an interface system for Timax. So
they're already connected to it.
So this system works now with Timax?
Yes. Yeah. That's it. Thank you very much.